We're going to start on probability today, and we're going to start on something I wanted to show everybody. And I want you to do this. Go to YouTube, and I think I put it in your, let me see if I did. You go to YouTube and pull up the library, of course. I hate it when you go to the home page because it's totally different from their playlist. Go to the playlist, which I can't get to, and just pull up Math 120 AM. I don't know what I can't stand to hear that. I don't know why it goes directly to the, I don't understand that. I thought when you click on the class, view full playlist, there we go. Down at the bottom, do y'all see the 4.1 and 4.2 correlation and causality, Math 103? Do you see that? Okay, I want you to review those. There's 3 of them right here, along with today's class. All right. I'm going to go over all this today, but I want you to go over these also. Capiche? So, starts 4.1, that's the Math 103 class, probability, and probability continued, and odds. I'm going to try to cover as much as I can, but over the weekend, I want you to go over these 3 videos over the weekend, okay? Very important, okay? All right, now, I'm going to go to the whiteboard, and we're going to do everything on the whiteboard today. So, causality and correlation. Correlation and causality. Correlation. Causality. And slope. Okay? In the Matrix 2, Reloaded, I think it's called, they go into the restaurant. They go into the restaurant, they're trying to find the keymaster. But they got to talk to the guy that's in charge of the keymaster, or whatever. And one of the lines in the, he's this French talking dude. You know who I'm talking about? Okay? And he goes, correlate, you're here for a reason. This is causality, cause and effect. I drink too much wine, I have to pee. Okay, causality. What is the difference between causality and correlation? Causality, there is a what? There is a cause to the reaction. Okay, I drink too much wine, I have to pee. All right, some of y'all can relate to that when you drink too much water, or you drink too much beer, or drink too much wine, or whatever the case may be. Drink too much whatever. All right, how about the more weight you put in a car, the less gas mileage you get. True or false? True. Okay? Just the same thing if you put a 10-pound pack on your back and you go 5 miles, can you do it faster if you have 25 pounds on your back? No. All right? So correlation and causality are not the same thing. Correlation, basically, is there a pattern? Correlation deals with just seeing a pattern. Causality, cause and effect. Are they equal? Hell to the no. Always remember that. Causality is not a product of correlation. Correlation is not a product of causality. Sometimes they do match up, but one does not cause the other. Okay? Slope has a direct correlation to correlation. Because you can see a pattern with slope and you can what? And you can calculate the slope. So if you have a positive correlation, then you're going to have a positive slope. If you have a negative correlation, you're going to have a negative slope. If you have zero correlation, you're going to have zero slope. Capiche? But correlation does not mean that you have causality. Let me give you an example. Let's say you do some research. And I just want to make sure I started the recorder. I want to make sure it's got a little red dot because I've got to go to another, this weekend, and my night class has to watch today's class. So that's why I'm checking to make sure it's recording. Yeah, it is. Okay. Okay. Let me give you an example of what I'm talking about. Let's say that you are a good probability and statistics student, and you want to find correlation and causality, and you want to see the suicide rate in Anderson County, suicide rate in Anderson County, and you see that it looks, looks something like that, and that's a scatter plot. So you see a positive correlation. We'll talk about this in just a minute. And then you go and you also work at M-Star 14 or whatever it's called up there, the movie theater. And at that time, and I'm making this up because Nicolas Cage film, let's say Con Air is played. Okay? Now I realize that's an older movie. I'm just making this up, okay? I don't need somebody pointing that out. All right, so this movie's playing, and there's a correlation of, there's ticket sales for his movie is really up because people, those are supposed to be dots, but for some reason this thing can't make dots. One day we're going to get trained on these things. I hope you don't believe it. Okay? So now I can say suicide rates in Anderson County have a causality or a correlation to Nicolas Cage movies. Yes or no? No. They do not have anything to do with each other. Do they have correlation? Yes. Causality? No. One does not cause the other. I just picked two things out of the air, and they both have correlation. Just because they have correlation does not mean they have causality. It's very important that you understand that because there are so many test questions that can be centered just around what is on the board right now. Versus weight of vehicle and gas mileage. What kind of correlation is that? A negative correlation. Does it mean causality? Yes. Okay? So make sure you understand the difference between correlation and causality. Correlation, pattern, just like slope. Is there a positive correlation? Is there a negative correlation? Is there a zero correlation? Correlation and slope have a lot to do with each other. Causality is for you to look at the two and say, do they have an effect on each other? If you pull two things out of air, no. But if you have two things that you are comparing that have to do with each other, yes. Okay? Now, let's go over a little bit of algebra. Don't mean to bore you. Some of y'all invented algebra. I understand that. That's why you're sitting in here. Let's go with slope. Slope is equal to delta y over delta x. What does that mean? The change in y over the change in what? Which means y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You also got the point slope equation. Point slope equation is y minus y sub 1 equals m times x minus x sub 1. You also got, when y is equal to a number, it's parallel to the x-axis, which means that the slope is equal to what? 0. It's supposed to be not sigma, but 0. When x is equal to a number, it's parallel to what? The y-axis, which means the slope is what? Does not exist or is undefined. Now make sure you remember how to do this. You're going to be asked this in your homework and on your test. I'm also going to show you how to do it on the Excel spreadsheet and the calculator a whole lot easier. Okay? For some of y'all that didn't invent the calculator. All right, so let's get 2 points. Now these 2 points can be given like a line and you find 2 points. A line and you're given 2 points like that. Or 2 points like 2, 0, 4, 4. Those are the 3 things that you could be given. Now, of course, those 2 at the top is graphs, meaning that you have to look at them and you have to find the points. Are they given? One of the 2. So sometimes it's not as simple as, you think. Which way do we read?
Left to right.
Left to right. So wherever you pick a point on these 2, read them left to right. This is x sub 1, y sub 1. This is x sub 2, y sub 2. This is x sub 1, y sub 1. This is x sub 2, y sub 2. Find the equation and the slope of those 2 points. Do that right quick. If you can't remember, that's fine. You're just a disappointment. And we'll go over it, and then you can fill in the blanks. If you're wondering why a lot of your teachers are going to conferences right now, sometimes we have to go to 2 a year. Now, the one I went to last time, that wasn't Philly, that was with something else. That wasn't Tri-County Tech, so this is my first one. And usually try to knock one out in the middle of the year, first of the year, and then you save your second one for summer. And you try to go somewhere good for the summer. You get it? So, if some of your teachers have been on conferences, that's why. They try to knock one out at the beginning of the year, and then during the late spring or summer, they try to do one like in Hilton Head or Myrtle Beach or Florida or whatever. I don't. I just go to Atlanta, Columbia, and if I have to, Charlotte, but I really don't like to.
Why don't they just do both of them during the summer?
Huh?
Why don't they just do both during the summer?
Well, the department heads like for you to do one as soon as possible. Therefore, in case the money runs out or whatever, if their budgeted money runs out, then you have to pay for some of yours in the summer or whatever, or they have to just pay for the room instead of the conference, or pay for the conference instead of the room if their money runs out.
Hey, why do you like going to Atlanta more than Charlotte? I would rather go to Atlanta than Charlotte.
I like Georgia.
You like the Atlanta traffic more?
Not really, but I'd rather go to Atlanta than Charlotte. I just don't like Charlotte. And I've been in enough big cities to where I don't care nothing about being in the big cities, so I usually stay outside of Atlanta. When I do go to Atlanta, I stay outside of Atlanta.
Where do you stay?
Usually I stay in Tucker, or I usually stay in I have stayed at Buckhead a couple of times, you know.
Okay. The state-
But I just don't, I don't sit there and go, oh, I'm gonna stay downtown Atlanta. No, I'm not.
Just stay out of Marietta and Cobb County, whatever you do.
Yeah, they're
Those two-
pretty bad. But my truck fits in pretty good there. No, I'm just kidding.
How's your transmission?
It's good so far. I pulled a load this weekend or last weekend, and it hadn't fell out yet. So evidently they finally fixed whatever they needed to fix. Okay, so plug and chug. Slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, if you was to walk into my office a year from now and come into my office and say, can you figure the slope for me? I would still use those parentheses. Why? Because there's two things that y'all don't like. What are they? In math. Fractions and negatives. And when y'all get those two things, y'all's head explodes. All right? Now, I'm not talking about y'all in here. I'm talking about students in general. And I've got several degrees, okay? I don't know how many degrees y'all have, but I've got several degrees, and I still use those parentheses. So if I use those parentheses, and I've got several degrees, what do you think you might want to do? You might want to use them. But again, I know some of y'all have doctoral degrees. So, 4 and 0, 4 and what? 2. And sometimes I still screw it up, all right? 4 minus 0 is 4, and 4 minus 2, so the slope is equal to what? So now pick a point. I'm going to pick this one. Why did I pick this point? KISS method. What's the KISS? Keep it simple, all right? What's it got in it that makes life easy? 0. So that's why I picked it. Y minus y sub 1, 0, equals 2 times x minus what? 2, right? I'm sorry, 0. Yeah, that's right. Y equals 2x minus 4. Now, you're going to see the same thing in probability, but guess what? That's redneck. So you got to spice it up for probability, because remember, probability is made by people that couldn't make it as a mathematician, so they just settled for statistician. So they have to fancy up all the words. Okay? You remember all the time in junior high and high school, you were taught y is equal to mx plus b. Everybody remember that? Well, they don't do that in probability. They change it. When you see your calculator, you'll see what I'm talking about. Are the fundamentals the same? Yes. So just don't even worry about what they call it. Just do it the way you know how to do it, and then just try to figure out. You'll see what I'm talking about when we do it on the calculator, okay? Now on the Excel spreadsheet, it does it like it's supposed to, but in the calculator it doesn't. Anybody got a question? Everybody remember that? Okay, same thing with correlation. Correlation, they're going to ask you if it's a positive correlation, if it's a negative correlation, or is it constant? Here's your 3 choices. You're going to be given a scatter plot. The scatter plot looks like this. Now these are all dots, and this thing makes it a line or whatever. That's a scatter plot. I think if I do it real slow, it doesn't have a fit. It's just like slope. Here, how do you read slope? Well, we read from left to right. Put a car here. What is that car doing? Downhill. So that means it's a negative slope. Means it's a negative correlation. Car here, going uphill. That means a positive slope, positive correlation. This means 0 slope, which means no what? Correlation. Now, can you have, I don't know how to spell correlation. Is it 1 R? Is it one? It's 1 R, isn't it? I think it's 1 R. I don't know. Y'all figure it out. Anyway, there will be strengths, okay? They will ask you about the strength. Which one's stronger? Which one's a stronger correlation? This one or that one? This one. This one's a stronger. Steepness equals strength. All right? Steepness equals strength. So if it's almost horizontal, that means it's very what? Opposite of strong is weak. The more shallow, the weak. The weakest, the weaker, whatever. The more weak. Same thing here. I can have a positive correlation, but it looks like this. Well, yeah. This one needs to go like that. There we go. More steep. This one is not as steep. So this one is weak compared to this one. This one is weak compared to this one. All right, so make sure you understand those 5 graphs because you're going to be asked about those on a test and standardized test. Make sure you can find the slope. Capiche? Now, you're going to be asked about some homework questions. It's going to have a bunch of tedious math and a bunch of... I'm not doing best fit with y'all, okay? I'm not doing line of regression best fit because that math is too tedious and that's what your calculator is for. All right, so we're going to go to the calculator, get your calculators out. And if you've got a laptop or whatever you call them now, tablet or whatever, get that out. You can pull up Excel or you can pull up, and I'm just going to put some points in, so you need to go to your stat and edit. And I'm going to show you how to do both. And this is how I want you to do it on your calculator and your homework. I mean, your test and your homework. I do not want you using, everybody understand this? I do not want you using the formulas by hand because that's just ridiculous. Okay, so let me pull up the handy dandy calculator. And while y'all are putting in the numbers, I'm going to be pulling up the spreadsheet. And then y'all can copy the numbers off the spreadsheet. Let's go with 18. All right, I'm just going to put some numbers in. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then I'm going to go over here and I'm going to put 5, 7, 4, 6, 9, 13, 12, 10, 15, and 21. Okay, do we have any idea what this looks like? No, we do not. That's the whole point of a scatter plot. So those of you that have your calculator, hold on, and we'll do the calculator after we do this one. So I highlight the 2 columns, and I go to Insert, and I go to the scatter plot right here. Is there a strong correlation? Yes or no? Yes. You take your handy dandy virtual line maker, and I'm going to do it in yellow so you can't see it very well, so don't bitch. And there it is. All right? You got a strong correlation, meaning that there is a pattern. Why did I put it right there? Because I think that's where the trend line is. All right? After you look at 5 or 10,000 of these things, you start to see where it is. And I could be wrong, but how do you find it on Excel? Well, you take your handy dandy mouse and you click on, left click 1 time, and it turns them all to X's. Everybody with me? Then you right click on one of them and it pulls up that menu and you hit Add Trend Line. Oh my gosh, I'm a little bit off. Now, look at here. You can display the equation and display R squared. Now, my trend line is a little bit off, but I eyeballed it, okay? There is your trend line. Y is equal to 0.7636x plus 1.8. You're finding the equation of what? The trend line. R is equal to 0.78. -1 to 0 is a negative correlation. 0 is no correlation. And 0 to +1 is a what? Positive correlation. So what's this one? 0.8. Is that a strong correlation? Anything over 0.5 would be a strong correlation. Anything below 0.5 would be a weak correlation. You with me? I don't know how much you know and how much you don't know on this, okay? So I'm just trying to go over everything, you know, where everybody understands. So make sure you can pull up a correlation coefficient. And of course you take, that's R squared. If you wanted R, you would take the square root of that. So somebody do that. What raise 0.7835 to the 0.5 power? What do you get? Okay, so R is 0.9. So yes, it's a very strong correlation. I forgot to tell you, you've got to take the square root of 0.7835. So make sure you add that in your notes. So what do? You highlight the X and Y column. You hit Insert. You go to the chart plot, and you basically hit the chart plot. Then you left click one time on the dots, data points, and they'll turn to X's. If all of them turn to X's, then you right click and go to add trend line and R and equation. We'll do it again in just a second. Now let's go to your handy dandy calculator. And we'll go to, since I'm the only one on campus that uses them, they don't set them up. Forget it. Stat, edit. 2, 4, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And go over to the Y. 5, 7, 4, 6, 9. 5, 7, 4, 6, 9. 13, 12, 10. 13, 12, 10. Make sure I don't screw it up. 15 and 21. Everybody with me? Now, go to second, Y equals, enter, on, hit enter, and it's already defaulted to chart plot, or whatever you want, scatter plot, and it's defaulted to L1 and L2, which is your first column and your second column, and hit graph. Now hit zoom, and I think there's a statistic zoom. Hold on. There it is. Zoom stat 9. And there is your data plot. Scatter plot, sorry. Does it look like Excel? Yes. Now how do you add the trend line? You go to stat, calculate, and what is this? Is it a linear, or is it a quadratic, or cubic, or quartic? What is it? So you type linear, and it'll automatically go to L1 and L2, but just in case, second 1, comma, second 2. That's L1 and L2, and hit enter. And there you go. Yes, sir.
Mine has an option for frequency list. It's set to L3. Do I just leave it blank?
Yeah, just leave it blank, because I don't think you have to worry about that. It should give you 0.7636 and 1.8. That's your y-intercept. Did it work? Mm-hmm. Okay. Now again, it's not as complete as the, and I think you can go, hold on a second, I have to look this up every semester because I forget it. Let me look up display R on TI 83. I have to look it up every time. And you have to go and you have to turn on, give me a second. Display R on TI on linear regression. No, it doesn't. You got to turn it on. Turning on R. Well, you got to go to the catalog, and I can't remember what the word is. Blame it. Usually, there it is. Diagnostic on. So go to the handy dandy catalog. Isn't it called catalog? Where's catalog? Is it second 0? And go to D. I guess you can type in D and it'll go to D. Alpha D. No, it don't. I hate calculators. So you got to arrow down. If you can find D on your calculator, good. Diagnostic on. Hit enter and enter. Now go back and do stat, calculate linear regression, enter, second L1, comma, second L2, enter, and there's your R, 0.885. Is that what you got a while ago for your R? I think y'all did because I said 0.9. Now, see, that should help some of y'all that didn't invent the calculator or wasn't on the calculator drill team 9th, 10th, 11th, 12th grade. Any questions? All right, let's do it in nerd, just so you'll have 2 in your, because that's all I care about. On the test, I'm going to ask you if there's a correlation. I'm going to ask about causality, and I'm going to ask you to find R, and I'm going to ask you to find the trend line. That's what I'm going to ask you to do. That's it. Whatever the homework asks you, just try to get through it the best way you can, okay? Because I didn't make those homework questions up, and send them to me, and we'll muddle through them as we can, because 4.1 and 4.2 is not supposed to be complicated. But this book makes it complicated because they want you to do it by hand. And I'm going to tell you, you do not want to do this by hand. You take a whole page just to do the columns and the calculations. You know how we did the columns with the standard deviation? Well, you got to do like 3 or 4 more columns than that. And it's just a pain. So I don't do it. You're welcome. I could make y'all do every single calculation on a poster, and you display it out in the lobby. Okay, you're not going to talk. That's fine. I'm trying to find the Excel spreadsheet. All right, you ready? All right, let's do 21, 23, 25, 26, 28, 27, 28, 30, 32, 34, 35, 37. And then up here, I'm going to go 17, 15, 13, 12, 12, 15, 11, 10, 6, 4, and 2. And of course, you're not worried about the categories. You're not worried about what they are. What you're worried about is finding the correlation coefficient and the trend line. So I'll let y'all do that on your calculator first. Those of you who work in Excel, do it on Excel. If you do it over, that's fine. Any of y'all ever had chia seeds?
No.
Yes.
They're pretty cool.
Is it in your drink formula?
Yeah.
How do you get like the consistency, the gooiness of it?
You put it in water until it breaks it all up. Can't even tell it.
Is it not a consistency issue for you?
Yes.
It can slide?
Oh, no, I don't care. Dog will eat turnip greens after 2 or 3 days. My kids, they can't stand to hear that. But it will. Jerry Clower, the famous long time ago, Southern storyteller / comedians, before it got foul mouth, just told stories and it was funny. He said a dog will eat turnip greens after 2 or 3 days. You hungry enough or thirsty enough, you what? You'll find something to eat or something to drink. I'm just saying, I don't care. It don't matter to me. The vodka covers it up. And those of you that goes to my department head and says I'm drinking vodka, she's going to know this is a lie because she knows I don't drink vodka. So,
Covering your bases.
yep. At least I'm going to pick a liquor that I don't like. Now, if it was bourbon, then it'd be different, okay? So I don't use bourbon. I don't use that as a joke because she might really think that I'm bringing bourbon to school. You got to have a sense of humor. It's part of life, despite what a lot of people in the United States think. Get rid of them farting cows. Y'all heard about that, right? AOC wants to get rid of cows. They pollute the air with their gas. I have to sell all my cows. The Russians will buy them. Insert. Oh my gosh. Think we're going to have a very, very high negative correlation coefficient. I'd say probably like 0.99 or 0.98. So I'm going to click on my handy dandy virtual, whatever that's called. What's that noise? Huh?
Somebody honking in the parking lot.
Oh, I saw somebody yesterday carrying a gallon jug of water around. And it was one of those you buy at daggum Publix. It was one of those clear ones.
Oh, wow.
Yeah, it looked like he needed to put a little bit of creatine and some anabols in there or something. But I'm not going to say anything. Shut up, Hubert.
No, be on creatine. That's why you're drinking all that water.
Yeah. All right. There it is. We're going to add you can also add the intercept if you want to, but that usually messes things up because it doesn't have an intercept because it's way the heck up here. So I wouldn't do that. Display and display. Somebody take the square root of 0.8841 or look on your calculator for R. What do you get?
0.94.
0.94. Okay, I was off. I said it was going to be 0.98. Is there a strong negative correlation? Yes. And this could, now what if this was ticket sale? What if the Y was ticket sales let's say this one. Let's say this one was ticket sales of your favorite actor or actress, and then the suicide rate in Anderson County, would you say there's causality there? No. Okay. What about the age of drinking goes down and the fatality rates of wrecks go up? Could there be a causality there? Yes. Okay, you got to put it in what? Two things. One starts with a C and one starts with a P. Context and perspective. Good job. Context and perspective. Kind of like sense of humor, you know. When somebody's kidding with you, you got to put it in context and perspective and not run off to the offensive closet. You get a puppy and a pillow. Questions on that? That's 4.1 and 4.2. Question? Y'all not going to talk to me? Okay, good. Everybody got it? All right, probability. I'm looking to see what time it is before you'll start going into convulsions. All right, probability. Probability, and some of y'all know where Wild Hog Road is, don't you? I'm sorry, it's Highway 187. No, it's not. It's Wild Hog Road. Highway 187 is out here at Ingalls, okay? That's Highway 187. But anyway, somebody decided to call Highway 187 up there toward Pendleton the same as Highway 187. Anyway, it's a long road. Goes by Pendleton High School. You know what I'm talking about? Yep. All right. Well, it takes about 16 minutes driving normally, not in a rocket ship like some of you guys claim you drive. Oh, I'll get there in 2.6 minutes. You know, whatever. All right. You know, there's always, when you go into a group of people and you say, I went to Panama City. You went to Panama City? Yeah. How long did it take you? 8 hours. Psst. There's always one guy in the group. Run, girls, run. Okay? That's the same thing as the milk jug and the eyeglass and the sunglasses in the gym. Yeah, run. Because he's got issues. Anyway, I can get there in 2.6 minutes. Yeah, whatever, bud. You're just Superman. Anyway, it takes about 16 minutes because I used to travel it every single day, every morning and every afternoon. But if you've got an 8 o'clock class and you get on 187 at 7:40, you can forget getting there by 8 o'clock. Why? Because one thing on Wild Hog Road, there's the Waffle House right there. Dang old QT's right over here. So some of y'all have no idea where Wild Hog Road comes out. And Pendleton High School is right there. My cousin's house is right across from it. And this is Double Bridges over here. Or for some of y'all that's not from around here, y'all call it the Twin Bridges. Good God. The Twin Bridges. The what? The Twin Bridges. You know, the two bridges that are together. It's called the Double Bridges, okay? Anyway, dang old Townville. T-Ville. Dang old, right there. All right. If you got on this road, the one thing about Wild Hog Road is if you get on it and you're in a hurry, there's a little blue-haired ladies club that owns Wild Hog Road. And the little blue-haired ladies club, they'll get right in front of you. Now, who is the little blue-haired ladies club? They're the ones that drive 33 miles an hour. Do not get above 33 miles an hour. Do not get below 33 miles an hour. Everybody with me?
Yes.
You get on there, you can forget it. It'll be 8:20 when you get to Pendleton. So, now what does this have to do? Well, how do you know you're in blue? You get on here, and you're talking about 15, 16 miles. I don't know, 8, 10 miles. I don't know how far it is. But anyway, you get up here, and you get to this part right here at Pendleton. Pendleton High School is about a quarter of a mile to Clemson Boulevard. And you get up here, and there's a turning lane to the left, and there's a turning left and right. Right about here, you get in front of Pendleton High School, or between Pendleton High School, you get about 500 feet from that, and you say to yourself, you already are road raging, okay, right? You already have tried to pass several times, but you can't because you get head-on collision, all right? Even if you're a Superman in the crotch rocket, or whatever you drive, that you can get everywhere in 2 minutes, all right? So you say to yourself, I bet this woman's going to turn left. And what happens just as soon as you say that? That left blinker turns on. Have you predicted the future? No, you haven't, because nobody can predict the future. Okay, she turns left and she gets in this lane and you go into full road rage. Okay, you're right here and it's already 15 after 8. Okay? We did not predict the future, because you cannot predict the future. Okay? If anybody tells you they can predict the future, all you got to do is ask them one question. Anybody know what that question is? Powerball lottery numbers. That's all you got to ask them. That's not what I do. Shut up. You're a fraud. Okay? Nobody can tell the future. Can I ask you 15 questions and find out what you're thinking? Yes. That's called what? Deduction. Y'all ever played 20 questions before? Okay? Same thing. What does an investigator do? An investigator deduces until whatever is left is what? The answer. All right? What do? We didn't predict the future, but we used experience. Sometimes we use mathematics, meaning statistics, or we use logic to what? To place a number on a prediction. Now write that down, because that's a Hubertism definition. That's not going to be in any book. All right? You're using mathematics, statistics. You're using logic, and you're using experience. Now, what did I tell you at the beginning of this scenario with Wild Hog Road? How long did 15 years I traveled down Wild Hog Road every day. I live in West Anderson. West Anderson is over in here, okay? From 29 South, Hartwell, Dam, all the way up to 28 Bypass. That's West Anderson, okay? Not the project, but some of y'all think it's the project, but it's not. We have a lake, okay? Anyway, you don't. Anyway, to make a long story short, everybody that lives in West Anderson knows, okay? What do you mean logic? What's logic got to do with it? Anybody that lives in West Anderson knows if you get on Wild Hog Road, you're heading one of two places. What are the two places? One's Pendleton. The other one is what? What's to the right of Pendleton? Sandy Springs. Okay? You're either heading to Pendleton, which is left, or you're heading to Sandy Springs. Now, why did I not know that she was turning right? Because how many roads are there? Here's 85. Okay, it goes under. Okay, the little house is right there. All right? There's like 3 roads that you can turn off to the right there behind Boscoville, that goes to what? Sandy Springs. So the logic says, if this woman is going to Sandy Springs, she would have turned right where? At one of those 3 roads. So logic dictates that she's going to turn left anyway. Does everybody see where I'm going with this? Anybody seen these people that say that they can tell your future? What's the first thing they start doing to you? Asking questions. Why? They're using deduction. They're using deduction, and they're using logic. If I go into your crystal ball room, and you're telling me the future, and you ask me, well, first of all, you want to know your future. That tells you that you're pretty screwed up anyway, right? Or you won't have fun with it. One of the two. All right? You're going in there and say, okay, this person's insecure because they want to know the future. the first thing you ask is, well, what kind of relationship are you in? And then the fortune teller basically builds your whole life with questions that they're asking. And they tell you where you're going. And of course, if you're one of these insecure people, then they're going to tell you that everything's going to be great, and you're going to get a boyfriend or a girlfriend, and you're going to, get rich and have babies and have a little house around. That's what they're going to tell you. Okay? So they're using not necessarily math, but they're using deduction, which is logic, and experience with people coming in there all the time, and they're deducing and telling you what you want to what? What you want to hear. Okay? Now, in math, we use records, we use surveys, we use polls to predict something. Can it be wrong? Yes. 2016 presidential election was very wrong. Okay? So, what keeps us from doing that? There's things in probability that we study, especially in 9 and 10, where we talk about confidence levels. But before we get to confidence levels, you got to understand what is your weakness in probability. Every student's weakness in probability is reading and knowledge. Well, what about the math? Math is real simple. What do I mean reading? Guys, what do we not do? We don't read the what? Directions. We don't read the question. We already know it all. So we already know what the question's going to ask before we get to the end of the sentence. Okay? Sorry, guys. It's in our DNA. That's why we drive around in circles before GPS. Because we know where we're going. All right? Okay? So you got to read. What's knowledge? Okay? If I was to ask you, one person in here, how many cards are in a deck of cards, 90% of you or 80% of you would tell me 52. But there'll be 5 or 10 of you that'll go, oh, I don't know what I do. That's the knowledge. You got to know what you're dealing with. How many sides of a die are there? 6. What is a die? Some people don't even know what a die is. It's one dice. Okay? What is a sample space? What is a sample set? What's an event? So, a lot of the problems in probability is those two things. You got to know what you're dealing with, and you got to be able to read the question. If I ask you what is the probability of having one girl with 2 children, you go, okay, that's boy, boy, girl, and girl. So 2 out of 4 is one girl. Okay? So that's 0.5 probability. How do you know that? Well, there's only 2 genders. Okay? There's male, and then there's what? Female. Unless something has happened to you on the genetic level, when you are introduced to this world, you're one of those 2 genders. Okay? Depending on what the plumbing is. Okay? So there's a 0.5 probability that you're a male or 0.5 probability that you're a female. You got to know that. What is the probability of a head on a coin? 0.5, because there's 2 sides to a coin. Now, there's 2 types of probability. There is what I call the theoretical probability. I don't know what that is. I don't know where that came from. Theoretical probability. And there is what I call the physical probability. The theoretical probability, if I ask you, what is the probability of picking a king out of a deck of cards, you're going to say 4 over 52, which is 1 over 13. Where's your deck of cards? You don't have one. It's based on nothing but what? Mathematics. It's based on nothing but what is assumed to be a deck of cards. You don't even have a deck of cards in your pocket, much less in front of you. but you're basing it on something that you already know. That's called theoretical probability. It's based on what? Mathematics and what we already know. Physical probability, and I'm not going to do it today. We're going to do it when y'all come back, because some of y'all will go into hysterics because it's already getting close to time. When y'all get back, we're going to, do this. And that is the physical probability. Now, the physical probability and the theoretical probability don't what? They don't match. Why? Okay, physical probability is actual observation or what? Actual observation or experiment. Okay? And here is purely what? Mathematical and what we already know. But they don't match. This would be 0.1/13, and you may do this deck of cards, and you may pick 0 out of 10 hands. You might get a king. 0 is not equal to 1/13. So how do you get the two to match? Well, in probability, there is a rule called, or the law of large numbers. Now, I'm going to talk about this and then we'll quit that. In MIT, there were 2 students. And the 2 students were probability students, mathematical students. I don't know what they were. But they were trying to figure out how many flips it takes a coin to get 0.5 probability. But they didn't want to sit there and flip a coin 500,000 times. So what they did is they took a roll of quarters, 2 students, and you can actually Google this because I think it was MIT, because this was in one of our books. And of course it was a great example. So of course what does Tri-County Tech do? Get rid of the book. Okay? Great example, so I keep using it. 2 students took a roll of quarters. What's the roll of quarters? 40 bucks? Or, 40 quarters. Isn't it 40 quarters? $10? Okay? Those 40 quarters. All right? And what did they do to those quarters? They measured them every which way but loose. Okay? They took an infrared micrometer and they measured each one. Now, of course, they took everything to the 10,000th of a decimal point. Okay? They measured the weights. They measured the balance. They measured everything you could. 5 or 6 different directions they measured each one of those quarters. And then they took all those measurements and they took an average and they got one algorithmic quarter. One algorithmic quarter. Okay? And they basically took that algorithmic quarter and programmed it into the computer in a program to do this experiment. Everybody with me? And they flipped that quarter so many times until the computer flipped it until it equaled 0.5. Anybody know how many flips it took?
2. 2,750,000.
Not that high. 100,000 flips. It took 100,000 flips for that computer algorithm quarter to get 0.49995. Now, of course, if they went 100,010, they probably got 0.5, but as soon as the computer read 0.499999, whenever, that's when it stopped. And it stopped at 100,000. What does that mean? Basically, the law of large numbers is a good way What is CYA in real world? Cover your backside, ass, mule, whatever you want to call it. Let's say that you work at Michelin or you work at First Quality and you are a quality assurance director, and you make $125,000 a year, and you work at the headquarters, which is in BFE, Atlanta, or whatever, okay? And your job is to get all of the companies, all of the different campuses, or all the different factories, or whatever, and project for the next year's quality assurance. So you go to a board meeting, and there's a budget meeting for next year's budget, and let's say I do the tires, because I can't sit here and do tissue paper, because I don't know, tissue paper, do you do it by the case, or I don't know about tissue paper. So you do tires, and the president, CEO says, okay, quality assurance director, what's next year's budget? Well, I did it, it's going to be around 26% of our tires at the Sandy Springs plant, the Anderson plant, and the Greenville plant. About 26% are going to be bad tires. So they say, okay, 26%. Okay, so we're talking about $1.1 million in next year's budget. Yes, we did. Okay? He was lazy, and he didn't pull enough tires. He only pulled like 50 tires out of each company, out of each factory, and just surveyed 50 tires. With me? Next year rolls around, and the quality assurance, defective tires is 56%, which translates into $5.6 million. What are you? Fired. Why? I made a mistake. No, you didn't. You're paid how much? $125,000 to do what? Your job. And you dropped the ball because you didn't pull enough what? Numbers. Numbers. Whether you are presenting or whether somebody is presenting to you, what always needs to take an effect is how many people were polled, how many people were pulled, how many people were surveyed, how many tires were pulled. The more, the what? The better. The more, the better, because you always want to get those two to equal. Capiche? All right, y'all get out of here today. You can probably start working on 4.1 and 4.2. I'll see y'all Monday. Or, I'm sorry. Whatever. Y'all know what I meant. I don't need anybody. We don't come to school. Shut up. Okay, somebody's going to get their ass beat. That's nice. That's like SpongeBob. I'm going to kick your butt.